Really?
Yep. 2 point something.
Oh, okay. It's not even worth mentioning. I don't know, since the first year I moved here, it was 2005, I felt an earthquake. I haven't felt any since then, but I thought somebody just dropped something really big on the roof of the place where I was living. It just felt like someone went boom and everything went but I'm fine. I don't need to feel another one. Especially not the big one that's just floating off. Floating off towards Hawaii. That's a lot of options there, Jeff. Alright, so to be really honest, yesterday was a rough day to miss. We did a lot. So a little quick review of what we did yesterday. We basically did section 8.2. We discussed the idea of the mean. So if you weren't here yesterday, that symbol is freaky. So remember, what does this symbol mean in English? Sum up these, right? And then n is going to be the total number of things. So in English, this would mean sum up all the values and divide by how many there are. We know that's how you get the average. That's what you would say in English, and that's what we write in Mathish. Mathish. And then we had the ideas. These are all ways to figure out the center of data. There's the mean, which makes sense. There's the median, which really makes sense because it's truly the middle number. And so that's all it is the middle number. And I gave you that little way to find it. It's to take n plus 1 divided by 2. I would really only do that if there's a really large sample. I mean, if it's small, you just kind of count your way into the middle. Not a big deal. If you had 5 numbers, the third one would be in the middle. And if you check it, 5 plus 1, 6 divided by 2 is 3. It's the third one. Yay. Right? So that's where that kind of comes from. All right, maybe. And then we got the mode. And the mode is the only one of these that works for non-numerical data also. But it's just the thing that occurs the most. So you can have no mode, one mode, you can be bimodal, you can be trimodal. And then what I say, if there's more than 3, then screw it. Right? So a real quick example. Sure. What's the mode or modes?
1.
Done. I love it. So I kind of tricked you out. So the mode is just 1. It's the clear winner. I know there's a couple 3s, but there's 3 1s. It wins. So don't just list all the ones that have repeats. That's not what mode means. Mode is what occurs the most. And here, 1 occurs the most, period. End of story. Right? Now, if I would have written 1 more 3, then it would have been 1 and 3.
5 more.
Yeah. So here the mode is 1, because 1 occurs the most. Bam. Right? Very, very straightforward idea. Don't make more of it than it is. And then we have mid-range. So when I talk about mid-range, I first had to tell you what the hell the range was to make it make sense. But mid-range is in the middle of the highest and the lowest. And you can always find the middle of 2 numbers by taking the average. So the mid-range will be high plus low divided by 2. And these are all attempts to find the middle of a set of data. Locked.
So for tutoring, like if I'm getting help on the homework, what should I say? What math am I in?
So for chapter 8, you're going to want to talk to statistics tutors.
Okay.
Right? And that's, you actually, I'm glad you brought that up. That's the hard part about this new class, is it's a mix of algebra and stats. So your algebra tutor might not be able to help you because not every the math majors don't have to take statistics, believe it or not. It's an option. I wish it wasn't just an option. Everybody should have to freaking take it, but some people don't. So if you want help with chapter 8, you're definitely going to want to ask for a statistics tutor. And they're supposed to have Stats tutor's on all the time. But not every tutor might be able to help with that.
Oh,
Just depends on if they are stats, if they feel comfortable with it, or if they've taken it, or what.
okay.
Cool. Good point, though. And then we also got into this. So this is all measures of center, and then we got into what we call measures of spread. Right? How spread out the data is. And then the most basic way to figure out spread is also the way that's least descriptive. And it kind of makes sense because it's such an easy thing to get. The range is just high minus low. Right, the highest number minus the lowest number. That's the range. That's how far your data ranges. But it's not good enough to really distinguish between. We saw 4 different data sets on that handout. They all had exactly the same range, but we all agreed they weren't spread out the same way. So I wanted a better number. And of course, if I try to make something more useful, it's going to also be more complicated. That's just the way it's going to be. So sure enough, now we got to figure out how to do this standard deviation. Gather. Make an E. There you go, Jeff. Good job. We're actually not going to use the SD. I don't know why I put SD. The letter we're going to use is S. It's amazing. But just in case, all right, SD, I mean standard deviation. Yes, ma'am.
On the sheet here that you gave us, what did we get for number 4?
Oh, so that's where we start talking about how they're spread out differently. So when we made the frequency distributions, we saw how some were really clustered in the middle. Like the very first one, it barely gets away from the middle. Just a couple data points get any away from the middle. So it's the least spread out. And the last one, most of the data is really far away from the middle. So it's the most spread out. So we're going to develop this number today. This is what I love about statistics. It's the most recent branch of mathematics. And it's also the most immediately practical application, practical field of mathematics. And it's also where you get to see like formulas being created. I want you to tell me this, so I'm going to make you tell me this, right? Normally when you come into background and say, y equals mx plus b, accept it, you know. And then you talk about why it kind of makes sense. Here we're like, I want to know this kind of thing. Let's make math tell me this kind of thing, right? I like it. Turn the bright light on, sit math in the chair, tell us it. Oh, okay. There. So I'm going to. So what I desperately want you guys to try to do is I'm going to do the first and second groups. I'm going to figure out the standard deviation, and then I'm going to have you guys do the last 2 groups. So I'm going to talk a little bit about where this formula comes from, why it makes sense. And basically on a test or something, I'm going to give you this chart. You just got to fill it in. So the math behind this is deceptively simple. And it really is. It's just a few steps. That's what makes it complicated, is there's several steps to it. So let me first ask you, looking at this, let's look at a different set of data to begin with. You can do it, Jeff. All right. Let me give you something to compare it to. Now, real quick, verify for me that both means are the same.
What?
Because how do you find the means? You just add them all up, divide by how many there are, right? So what's the mean for both of these?
15.
So when you add them all up,
15 divided by 5 is 3.
yeah, you get 6, 12, 15 divided by 5 is 3. And here you get 6, 12, 15 divided by 5 is 3. All right, maybe. You guys cool? Okay. All right. But obviously this one and this one are different in their spread. Which one is more spread out?
The top. Wait, the bottom.
The second one. Please let that be obvious, right? Does the first one get very far away from its mean? No, just a couple. Does the second one? Oh yeah, it gets much further away from its center, right? On average. So that's what I want the standard deviation to be. I want it to be the average distance that the data points get from the mean,
Okay.
right? So like this data point, it's equal to the mean, and so is this one, and so is this one. So they got 0 away from the mean. How far is 2 away from the mean? 1 away. Okay. So that's the first step, is that simple thing we just did. Subtract. See how far apart they are. Isn't subtraction the operation to see how far things are apart? So let me do this first one. Got it. So 2, 3, 3, 3, 4. So the very first thing we do is, if I want to get an average, let me ask you this. If I wanted to get an average age in here, what do I first have to get? A list of what? Ages. If I wanted to get the average shoe size, I have to first get a list of shoe sizes. So if I want to get the average distance from the middle, I have to first get a bunch of distances from the middle, and then I can try to average them up, right? So the very first thing I want to do is, how far away is each data point from the mean?
Okay.
Now you will notice a little something maybe a little funky for this first one. What would it be? It would be 2 minus 3, which is? Negative 1. And that makes sense because it's 1 below. And of course these are going to each be 0, because 3 minus 3 is 0. So what am I doing right now? I'm just subtracting the mean from each data point. 0, 0, 0, and here it'd be 4 minus 3. That's crazy.
Okay.
But now notice, just to kind of cut to the chase here a little bit, when you add these up, what do you get?
0.
0. So that's, because that stupid negative there, right? So I could take an absolute value to get rid of the negative symbol, but what we do, for several good reasons, is we square them.
Make that harder.
Yes, exactly. We're math people. We're like, it must be more difficult.
All the time.
Let me ask you this real quick, just to make a little sense out of this. Does anybody know what the absolute value looks like if you graph it? Oh, shit.
No.
Does anybody know what a parabola looks like? X squared.
Yeah.
If you graph it, what's it look like? Looks like this, right?
Here.
Absolute value would look like this. So absolute value would look like this, and a parabola looks like this. So in math, this little hard turn is not good. We don't like it. There's a lot of math that can't handle this kind of sharp turn. In fact, just stay with me for a second. Isn't the slope here just straight down? And the slope here is just straight up. It's big negative, big positive. So what's the slope right at the center? It's freaky. Do you want to be in this airplane? Hell no. You're all dead. Right? All right, we're going to boom. You're just all up in you're dead. I'd much rather be, all right, let's take this turn. Not like that other plane. Holy shit. Right? So the same, it's kind of related exactly to that. The same reason I wouldn't want to be in this airplane is why math doesn't like this function. So we don't use an absolute value to kill the negative. We square it because it ends up with a much more well-behaved function, a plane I'd rather be in. Okay, but both, either absolute value or squaring does what I need it to do. It gets rid of the negative.
So it moves it.
But what do you think I'm going to have to do at the end to undo this square? I'm going to have to take how do you undo squaring? Square root. Yes, the opposite of squaring is square rooted. I like it. Oh, you guys are excited. So this whole thing I told you, I didn't even have to really tell you, but I saw a few people I thought maybe I should tell you why. So if you didn't really understand this, don't worry, it's okay. But why am I squaring? Just to kill the negatives, right? Because what do I want to do? I want to add up the distances and divide by how many there are. But if I do that, every time this is going to be 0. Do you see that? If I subtract the mean away, there's going to be equal negatives and equal positives. It would always be 0. Shit. So I better get rid of the frickin' negatives. And now I try to discuss why squaring is the better option. So of course now it's going to be what here? 1.
0, 0, 0.
Okay, cool. And there's one last weirdness, but I desperately want you to still understand it. We are taking an average. That's the idea of standard deviation. It's an average distance. We had to square the distances, so at the end I have to take a square root. So I kill that square that I did. So here's what we do. We add up all of these, right? Is that cool? We add them all up and divide by how many there are. Here's the last little weirdness. Because this is a sample of things, I have to adjust it a little bit because it's just a poor little sample. So what we normally do is we don't divide by how many there are, we divide by one less.
So that's what you do at the end?
Yeah. And again, I could tell you why that's true a little bit. So let me try. All right. Now again, the actual computations you have to do here are not difficult. This is still relatively new to us, but hopefully from the other day you understand the calculations involved here are not difficult, right? It's just remembering how to kind of work this kind of thing. I have to make a table of those. We got those. Then I can add those up. Bam, I'm going to get what? 2, right? It's amazing. So it's not difficult math. It's just the symbols we're using are a little bit different. But if you remember what they mean, easy math. Now, just to explain this real quick. There's an average age of everybody in this room right now, of course, right? It exists. There's an average age of everybody. If I pick one row of students, will their average age be the same as everybody's average age? I would put money on it not being. It's possible, but it's much more likely that it's not going to be the same. Let's just say, for the sake of argument, that these people happen to be younger than the majority of the rest of us, right? Especially because it doesn't include me. All right, you guys still with me? So there's an average age for everybody. Their average age, I'm saying, let's just pretend like they're all younger. So their average age is smaller. So each of them will be closer to the average age of them than they would be to the average age of everybody. Let me let that sink in. And again, I'm explaining something right now that you don't have to completely understand, but I just want to give you a full picture of why the hell this shit is there. So to adjust, so their standard deviation that I calculate is going to be smaller than it should be, because they're all going to be closer to their mean. So then how do I make a number bigger? I divide by less. Why is it exactly n minus 1? I'm not going to get into that, but at least it makes sense. I'm going to divide by a little less to adjust for the fact that it's just a poor little sample. Okay, so if you didn't quite get that, just take it. So here's the idea, though. I can still see the idea. I want to get an average distance. So I am summing up the distances and dividing by how many there are. I had to square to kill the negatives, and I had to subtract 1 to adjust. But it's still adding these up and dividing by how many there are. That's an average. So I will end up with an average distance. So this right now, we use s squared for. Why does that make sense? Because what have I not done yet that I need to do?
Something.
Square root.
Oh, yeah.
Remember, I squared all the distances, so at the end I better square root to kill that. So we give this the symbol s squared. This is called the variance. And when I take a square root, that's my standard deviation. Oh, shit. What I desperately want you to get is, was it difficult to make this column? No. Was it difficult to make this column? No. Is it hard to add these up? No. Is it hard to remember that's what that means? Maybe because this is new, but it just says add all of these up. Okay, I need to make them first, and then I add them up. So what am I going to put right up here for this problem? What's going to take that guy's place? 2, because when I add these freaking things up, I get 2. That's what's new also. You're used to algebra. You have a single letter that you put a number in for. Well, here, this whole damn thing is 2. You don't put something there. You don't put something. The whole damn thing is 2. What's the sum of these? Freaking 2. Right? So what would this be? This would be 2 over... How many are there?
5.
5 minus 1. So 2 over 4, I get 0.5. And that is the what?
The range.
The variance.
Variance.
And then I have to square root it to get the standard deviation. We got to kill that square that we did to kill the negatives. We got to undo that square. So what's the square root of 0.5? It's like 0.70 something, maybe. Well, it's 0.707. Somebody doing that for me? No? No calculators,
What do
didn't
you
you?
need? I'm still,
I understand.
um,
0.7071.
Oh my god.
Roughly, so approximately. All right, let me let you finish copying all that. And then we'll review it real quick again.
Are we gonna review the sheet?
Say again?
Are we gonna review the sheet?
Review it? No. Yeah, we did all that yesterday, so I'm not gonna redo it. All right. So I know it feels like I just unleashed a lot on you, but can you identify? So if I wanted the average of anything, yeah, of course. If I wanted the average of anything, I would add them up and divide by how many there are. Now, there's a couple things I had to do. I had to square to kill the negatives. That only makes sense. Because otherwise, it's always going to add up to be 0. What kind of good use is that? That's stupid. And this thing, hopefully you understand a little bit. If you totally don't understand, is still about n. Especially if n is really big. If I had 80,000 people, and then I divide by 79,999, ooh, that's a big difference, right? So it's still dividing by how many there are. It's adding up the distances and dividing by how many there are. That's the average distance. That's the average distance from the middle. I like it. It's a little more complicated because there are a few things we had to adjust for. But that's at the heart of it. That's what this is telling me. So this wasn't given to us by aliens. We constructed this to do what I wanted it to do. So let's try this out on the first set of data. And then we'll do the second set of data together. And then I'm going to have you guys do the third and fourth. So what do we got?
that's what the video's for.
Sure. So this first set of data, I have what? 8, 13. Okay. And then a 20. Now we already know going in that the number we calculate here for this should be small because most of the data is right on top of the frickin' mean. So the average distance that each data point gets away from its center should be small. Because most of them are like right on top of the damn thing. So when I do this, what's the next thing I do? I take each data point minus the mean to see how far away it is. Remember, the mean here was, of course, 13, right? Mm-hmm. So what's 6 minus 13? -7. And then all of these are going to be 0. And then what's 20 minus 13? 7. That's crazy. And again, a nice quick check to make sure that you're thinking about this right is this has to always add up to be 0. Because the mean is going to have equal amounts below it as it does above it. That's actually what the mean does. Not equal number of data points. That's what the median does. But an equal value below, as much negative as there is positive if I subtract like this. So this is always going to add up to be 0. The sum of these will always be 0. That's why we do what we do next. What the hell do we do next? Square these. To kill the negatives so that they actually add up to something useful. Yeah, so what do I put? What's negative 7 squared? 49. There you go. And the 7 squared? 49. So be careful, the other one was just ones.
Yeah.
Right? You have to actually square it. And please, dear God, don't let any negatives still be here, right? When you square real numbers, they come out positive. That's all there is to it. So when you add these up, what do you get? 98. Now, here's a good skill to have. What did you just do? You added up what? These. You added up these, right? So that 98, the symbol it uses is that. That's the symbol for the 98.
Okay.
Because where did it come from? It came from adding these up. So adding these up gives me 98. So if I see this in a formula somewhere, I can replace it with 90 frickin' 8, because that's what it is. Okay, I like it. Maybe. Add them up, divide by how many there are. That's basically what we're doing.
And then square root 98.
Beautiful. Well, square root, hold on.
I don't know what I'm doing.
So now we got, there's a formula for it. Now I know your brain is kind of like constantly, your brain will look at that, it'll forget all of our conversation, and it'll go, what the freaking shit is that? Right? So you got to say, brain, calm down, man.
Screaming louder.
Brain, calm down. X bar is the
Me.
mean. So X minus X bar is how far each data point is away from the mean. Okay, that's the heart of what we're doing. This symbol means add them up. We squared to kill the negatives, right? We're dividing by about how many there are, so I get an average, right? So the formula makes sense, but it's full of a lot of shit that's relatively new to us, so I understand why your brain might go, ah! So what do I put on the top there? That's what it is. Look, it is 98. Don't put something here and something here, right? This whole damn thing is 98. Why? Because the sum of these was 98. And what goes on the bottom for this? How many data points did it have? 10. So S squared is 98 divided by 9. So 10.88 forever.
Yeah.
I like it. All right, let me stop there for a second.
Okay. I'm just kidding.
And now to get, so this is the what again? This is the, what's that word?
SD.
Variance. I like it. And that part, the variance, it's how much the data varies, right? The variance.
Because it ends right there. Ends.
Sure, whatever sticks in here. And then, of course, what I have to do to get S, I have to take a square root. 3.998. Freaky. I like it.
And then,
All right, let's do another one together.
yeah, I get it.
And then I'll unleash you on the last two. This is unbelievably useful. Very quickly, while you guys are still writing that down, just to give you an idea of how this is used. When I give quizzes and tests, I expect the grades to have a standard deviation around 11, 12, 13, because that kind of goes along with a healthy range of grades. So if everybody gets an A, you might think, well, then that's great. You're a great teacher. Yay, yay, yay. But it might just mean that I made too easy of a test. I need to be able to distinguish between how much somebody knows of the basic shit and how much somebody's able to do more advanced shit.
Yeah.
So I need kind of a range of grades for it to make some sense. So if I get a standard deviation around 11, 12, 13, if I get it there, that's normal. That's good. So, for example, our quiz 1, the average was 79.6, and the standard deviation was 12. All right, good. I like it. For quiz 2, the average was an 83.6, and the standard deviation was 10, which is okay. So the average was a lower B, and people didn't get very far away from that. The grades didn't get very far away from that. That's what the 10 means. Not as far away as normal. You guys kind of get... So just knowing those two numbers gives me a way to feel out something like a test or a quiz, right? If I had a test or quiz that the average was 94 and the standard deviation was a 3, I did something very wrong, right? More than likely. Now, there's always a chance that everybody just happened to understand everything and my test was actually a good level and everybody just did really good. But because of random picking by students, I'm always going to get students who are less prepared for something, students who are more prepared for something, and then all the students in the middle. So I'm almost always going to get this kind of bell curve, right? I don't force that to happen, but if it doesn't happen, I have to assume that it's something I did wrong. I didn't make a good enough test to distinguish between everybody's different levels of understanding. Okay, that was probably too much that I let you in on. But this is good. I mean, this thing is so freaking useful. The standard deviation is so immediately useful in so many ways. So let's do another. Here we go. So this next set of data, should its S be bigger or smaller than that? The next set of data, group B's data, is it more or less spread out?
It's less spread out. It's all in the middle.
So group A, the one we just did,
It's more.
was the least spread out data, right? Because they were all right on top. Group B versus Group A. Is Group B more spread out or less spread?
Yeah, it's
More spread out. Okay, and I don't want to lead you there necessarily, but it's the truth, so I definitely want to kind of get you there. All right. Erase all the rest of this stuff.
13.
How could you tell that by just looking at the group?
So see the first one? There's only 2 data points that get away from the mean, right?
Oh, I see.
There's 8 that are equal to the mean.
That's the-
Right? In group B, there's 1, 2, 3, 4, 5, 6, 7, 8 data points that get away from the mean. They don't get very far, but they are not equal to the mean. They get a little bit away from the mean, so that's more spread out. And then group C, of course, is even more spread out. Okay, good. So let that make sense. So I can just look at these, and they are in order in terms of spreadness, right? Group A is least spread. Group D is the most spread. So I expect what we're about to calculate is going to be more than 3.2998. And if it isn't, something went really wrong. So let's see here. We got 6, where'd it go? 10, 11, 12, 13, 13.
14, 15, 16, 20.
14, 15, 16. Thank you. I like it. Some of you guys might realize that on Group A, isn't this a 13? In Group A? And this is a 13 in Group A? So I just took this down by 1, took this up by 1. That keeps the average the same. Took this down by another 1, took this up by another 1. Right? That's how I made this so that it would have a 13 across the board for the first part of that. So 13 is still the mean. So what's 6 minus 13? Like we got before, what's 10 minus 13? Negative 3. 11 minus 13? Negative 2. You guys with me?
Yeah.
12 minus 13. And of course these two are going to be 0. And then 14 minus 13 is 1, 15 minus 13 is 2, 16 minus 13 is 7. Now, this data is symmetric. Do you guys see what I mean by that? If you start here and you go out, it goes down by 1, it goes down and up by 1. It's symmetric around the middle. So see how these are symmetric. But even if it wasn't symmetric, all the negatives and all the positives would cancel, you get 0. That's always going to happen here, and that's why we have that third column, so that we don't let that happen. All right, so sure enough, this does sum up to be 0 like it's supposed to, so I know I'm on the right track. And now what's going to happen here? 49, 9, 4, 1, and then the same numbers again, right? Because it's symmetric. So don't look for this always, but this one happens to be symmetric. All right, Jeff, you said that word enough. Okay. Don't like that word. Is that 126?
Yeah, 126.
126, right? So if you add all these up, that's 126, and put for yourself, this is for yourself, not just for me. Tell yourself what the hell you just did. You just added up the x minus x bar squares. So anywhere you see this, you can replace it with 126. I like it. So this is not a huge step away from basic algebra plugging shit in. It's not a huge step away from it, but it is different. So here I get What goes on the top? 126. And of course I had 10 minus 1, 9.
Yeah.
14. Ooh, I like it.
And then you square root that.
And then you square root that, I like it.
714.
Who is it?
3.742.
And the one we just got was 3.2998 or something like that. What is it?
Yeah.
The one we just got a minute ago, this is for A,
Yes.
and this is for B. It is bigger, like we knew it would be. So that is a good measure of spread. If I make data that's a little more spread out, the number that I've chosen to represent spread gets a little bigger. Oh, thank God. All right, so you guys, you can team up with somebody else, and one of you can do group C, and the other can do group D using the table on the back. Unless you've already used that table, then just use scrap paper. Oh. So do group C and group D. And of course, group C should be a little bit
Even bigger stuff.
bigger than this, and then group D should be the biggest one, because it's the most spread out.